Hello, I'm David Kurzel, and this is another one of our video presentations about how Spraymation equipment works. The video today is going to be about timers, pattern controls, whatever you want to call them. The most basic electronic pattern control is a delay-on timer. If we have time going along, we have our actuation signal. We start an electronic timer. As soon as the actuation signal is received, and this timer is a delay. And it allows fine-tuning of when the dot of adhesive or the line of adhesive is going to begin based on the actuation signal, which is usually a proximity sensor or a photo sensor, or maybe even something from the machine's PLC that picks up this point. But we know we really want to do it a little later. So this is the delay time, and nothing happens. It just waits. In most of our, in fact, all of our timers, it can be programmed in tenths of milliseconds or in full milliseconds. Then once the delay time is over, the signal comes out of the timer, turning the gun driver on, which turns the gun on. And this is the on time. Also programmable in delay-on timers in milliseconds, tenths of milliseconds, as required. There are jumper selections on the back of the timers. So this gives you a real basic way of controlling an exact on time and having this a little bit of a delay adjustment. Now, all of our timers use crystal time bases. They're all accurate to a microsecond, which is a millionth of a second. They're just absolutely accurate. There's nothing in them to adjust. There's nothing to change. There's nothing to be off. A lot of competitive timers that do this, they only have adjustments that are in 1 millisecond increments. So we have a lot finer adjustment on our on times and our delay times. We find that with the electromagnetic guns, especially if you're doing a small amount, like a dot of perfume or just some kind of very small dot in a packaging application, that a couple tenths of a millisecond is actually visible on the product. The gun is so repeatable and responsive that we can deal with those kinds of response times. While we're still talking about the kind of simple stuff, I think we need to talk about one thing about this actuation signal. Some actuation signals come in, and they'll come along, they'll rise, and then after this, anywhere out here, we don't care what happens to it. We don't care if it goes down here. We don't care if it goes down here. We look for the rising edge on the actuation signal. We don't care about where it turns off. It doesn't affect anything, just the rising edge. One of the problems that happens, especially if you're doing very fast things, say your on time up here was, say, 4 milliseconds, and you had 0 delay. So as soon as you push that button, the gun's going to get actuated for 4 milliseconds, and that's it. If you're doing this with a mechanical push button or a mechanical relay, they're mechanical devices. They have a contact that hits another contact that's driven by a spring. And a lot of times, when these contacts come together, they come with enough force that they bounce apart and come back. So instead of being a nice clean thing like I've drawn here, it'll come up, it'll go over, come back, do this a few times, and then it'll stay on. Okay. If these times are longer than your on time, you can get multiple actuations because these things will happen fast enough to cause the gun to be re-triggered. Okay, we have a lot of old traditional timers. We'll be looking at timers in another video, the actual physical devices. And we have a new modern LED version of a timer that has push-button programming. That's a really nice delay-on timer. In the past, we've used timers that had a motherboard and a number of small control boards, input boards, and configured them into different kinds of more complex timers. And that's what we're going to be talking about here, is more complex timers. Today we have one basic timer pattern control unit that has an LCD display. It has a few push buttons. It's got menus in it for configuration and things. And from that basic timer module, we have two series of pattern controls. So we have the 3470 and the 3480. Since they're both based on the same basic timer, the difference is the coils that they drive. This drives a 120 volt AC coil with a 3010 46 gun driver. This is a traditional gun driver, traditional coil. This is the closest thing related to the previous series of timers, the 3200 series. The 3480s do a 24 volt DC coil, and they use the 305910 gun drivers. So they're the more modern low voltage ones that can operate on 120 volts or 240 volt power sources. Other than the gun driver, these things function, they're programmed, everything about them is identical. When we just talked about delay on timers for a very basic timer, this timer, instead of just being delay on, it still has an actuation signal, and it still has delay, and then it has on, as you'd expect, but it actually has another delay, and another on. So this is on 1, on 2, on 3. Each of the delays, each of the ons are individually programmable. They don't have to be the same, they can be completely different. They can be set up in milliseconds. You don't have to use, if you want to put 0 in there, you don't have to use it, so you could just have 2, or you could just have 1. It's very flexible. It gives you a lot of opportunities that you wouldn't have had with the other timer. In fact, with the other timer, you would have had to take 3 of the old timers and put them in series where one triggers the other one to get this kind of operation. One of the other things that this timer does is it gives shaft encoder, we call it SE, control of the on and delay distances. A shaft encoder monitors the speed that a shaft or a wheel is turning at. And by monitoring that speed that the wheel's turning at, you know how much distance has gone by. So if you get a -SE option on your timer, instead of these distances and on times being milliseconds, which that distance changes depending on the speed of the machine, you can actually have this programmed in inches or millimeters. And this could be inches, millimeters, all the way down the line. So if you're doing something, say you were doing something like flap on a box, okay? You knew you needed to wait exactly this far before, to get past the tapered part of the box. You needed to go this far to coat the flap of the box. You entered this distance, you entered this distance. If you need multiple ones, you could enter all these distances. For something where the machine runs at different speeds, this is the way you get exact placement of either the dot or the bead of adhesive. One of the problems with this is, if the machine is running very slow, this time is long. If the machine is running fast, this time gets shorter. So what if you really want to go delay 1 inch, and then you just want to put down a teeny dot? We've given you the option that if you want, in addition to inches, millimeters, whatever, you can also have either of these as milliseconds. So if you had an application where, say you had a package of some kind of disposable product that was 6 inches long, and you trigger at the beginning of the package, you wanted to put a small dot of fragrance in the middle of the package, you could wait 3 inches, and then instead of using inches for the on time for the fragrance, you could turn the fragrance on for 5 milliseconds. It gives you a very precise way to get a specific amount, a timed amount at a perfect location. Okay. There are a couple other things that these timers can do. Another thing that they can do is called stitching. And stitching is very similar to what we're showing here, but you can enter a delay, an on time, or on distance, either one, and then a number of stitches. So if you wanted to say you had a long product and you wanted to have a series of little dashes of glue or a series of little dots of glue, you could set this up, program in the delay, how big a stitch is, how far between stitches or how long between stitches, the number of stitches, and it would put down, say, 15 stitches in 15 inches of just little dots along your product. There are also ways that, just like with the previous timer, you can combine 2 timer channels into one. The basic timer has 4 channels. If we're talking about the 3480 timers, they come in a -1, 2, 3, and 4 option level. This has 1 gun driver, 2 gun drivers, 3 gun drivers, and 4 gun drivers. Then they'll get options like, if they have a shaft encoder, if you need that, then there'll be an SE here at the end of the part number. Very simple. Today, if you get something like a 3480-1 SE, everything's included. There's a complete system in a box. You can add gun drivers to have the system grow. One of our next videos is going to be going downstairs and actually touching and poking and trying to program one of these and show you the various parts in one of these timers. Thank you.